Hello ladies and gentlemen, my name is Hernan. I'm from Durango, and I'm studying mechatronics at the UTDBs. And now I'm going to talk about control system. What a control system is? Well, a control system is a device or set of devices that manages, commands, directs, or regulates the behavior of other devices or system. As we can see, a control system is a controller, system, and measurements. The measurements could be for irons, air conditioners. It needs to measure the temperature, and then the system will work with that temperature. Now let's continue. I'm sorry about that. Nowadays there are two different types, common classes of control system, which are open loop and closed loop control system. In open loop control system, output is generated based on inputs. In closed loop control system, current is the output is taken into consideration and corrections are made based on feedback. This means that the closed loop control system needs a feedback from the output that goes to the input, whereas the open loop control system, the output needs a response from the input. Now let's continue. An open loop control system, a control system in which the control action is totally independent of output of the system, then is called open loop control system. An example of this would be the slide or every single room that we have. In this case, the output would be the slide and the input is the switch. The switch now gives a current to the input, but if I turn off the switch, the slide will be off. It means, it explains what I just read about that. And if I turn on the light, it means that the input will generate current that goes to the output. Now let's continue. There are open examples in here: the light switch, lamp filament, and glaze bulb. This is open control system. Other devices are electric hand dryer, automatic washing machine, brake toaster, automatic tea coffee maker, slide switch. If we notice open loop control system, it works with a switch. It just needs a response from the input to the output. It doesn't needs a feedback from the output as the closed control system. Let's continue, guys. Closed control system is a function very different than the open loop control system. In this one, the control system in which the output has an effect on the input quantity in such a manner that the input quantity will adjust itself based on the feedback that is generated from the output that goes to the input is called closed loop control system. In this part, we can see there is an input right here, and the current goes on this way to controller and process, and there is an output, and we can see the feedback that goes to the input, and the feedback goes to the output. So that's why we call it closed loop control system, because this is a device or set of devices, a system that is their controls works in a closed way. Let's continue. A practical example of closed loop control system: automatic electric iron. As we were saying, the iron needs to regulate temperature. Heating elements are controlled by the output temperature of the iron. Servo voltage stabilizer, water level controller, missile launched and auto-tracked by radar, an air conditioner. I have an air conditioner right here. Now the temperature is 71 and set at 62. Now the temperature is supposed to be heat, but then when switch to cold, the temperature will change to 68. And as you can hear, there is an effect on the air conditioner. It's trying to regulate the temperature of the room. Now let's continue, guys. There are features of control system. The main feature of control system is there should be a clear mathematical relation between input and output of the system. When the relation between input and output of the system can be represented by a linear proportionality, the system is called a linear control system. There are requirements of good control systems. Those are accuracy, sensitivity, and other ones that are noise, stability, and bandwidth. Many people don't know what a bandwidth is. An operating frequency range decides the bandwidth of control system. And this bandwidth reports for devices that works with frequency. For example, an oscillator or any another kind of system. For example, a radar. That would be a good example of that. And it needs speed, oscillation. Sorry about that, guys. Let's continue. In this example, there is a comparison between those. In the left side, there is an open loop control system, whereas in the left side is closed loop control system, and it works differently. In the open loop control system, the feedback element is absent, whereas in closed loop control system, the feedback is always present because it needs a feedback from the output that goes to the input, whereas the open loop control system doesn't need a feedback from the output. Therefore, it works only with. I'm sorry for the inconvenience, man, ladies and gentlemen. Now let's keep explaining about this. You cannot see very well. Well, as we were saying, open loop and closed loop control system, it seems backwards, ladies and gentlemen. I don't know why, but we need those in for our life. Okay, now we can see another example would be that in this is an economical open loop is economical one, whereas the closed loop is a expensive one, is costly, man. For example, a washer machine. This is a closed loop control system. You just need to know the action. And for example, this is a direct water cotton washer. And it has the temperature, but it doesn't know the temperature to do the action. Just when you press the button, and it's going to be light. Now, once I press the button, it has a response that goes to the output. In this case, the input will be the button, and the output will be the response for the water. I mean, the device that give the water out. And now if I press the button, it will turn off. And the dryer is another example, closed loop control system. You just need to the temperature, the